For this video, we're going to find a formula to solve the number of terms in the expanded form of a squared polynomial. Now, before we start, we need to know the basic steps of expanding squared polynomials, which are things like this, where there's multiple terms and then you square all of them. The first step is to square each term, like this, 2a to 2a squared, 2b to 2b squared, 3c to 3c squared. And then you add twice the product of all possible non-identical pairs or combinations. So, for example, 2a times 2b would be 4ab, and then you multiply that by 2 for 8ab. And I sure hope I didn't make any mistakes here, because they'll be very embarrassing. And so we can use the steps to find the number of terms in expanded form. So the first step leaves us with the same number of terms as the unexpanded form, and let's call that number n. So for example, here we got 3 terms in here, and 3 terms out here. They're the same. Let's call the terms n. So for this, n is 3. The second step is more complicated, as we need all possible non-identical combinations, meaning that 8ab is already here, so you can't have 8ba, which is the same thing. It needs to be unique. Now, how can we find the number of terms in step 2? We can do it manually here. So let's say we got a list of letters, A, B, C, D, E, we got 5, so n is 5 in this, and A can pair into A, B, A, C, A, D, and A, E, which is 4, 1 less than the total number of terms. B can pair into B, C, B, D, B, E, which is 3, 2 less than the total number of terms, and C can pair into C, D, C, E, which is 2, 3 less than the total number of terms. D can pair into D, E, which is 4 less than the number of terms, and E doesn't pair into anything, which is 5 less than the total number of terms. Now we can see a clear pattern here, with each letter being able to pair 1 less than the former until no combinations are left. For example, A can pair into 4, B can pair into 3, C can pair into 2, D can pair into 1, and E can't pair into anything, which is 0. So we can write this as a formula with n representing the number of terms. So n minus 1 would be, in this case, A. A can pair into A, B, A, C, A, D, which is 4, 1 less than the total number of terms, 1 less than the total number of terms, and so on. 2 less than the total number of terms, 3 less than the total number of terms, until there's 0, which would be E in this case. And by adding this to the first step, which is n, it leaves us with n. We just add n to our formula, which is n plus n minus 1, plus n minus 2, plus n minus 3, until n minus n, which is 0. It's not really important, but I just left it here so we know the formula ends here. But this formula is way too long, you can't use it for anything, and it's basically useless. But something to realize from here is that the numbers are consecutive, but backwards. Now, that means the numbers increase by the same amount each time, but it's backwards. So it decreases 1. But in any case, we can just move that formula around. And now with consecutive number, we can use Carl Gauss's formula, the famous mathematicians, also called Gauss summation, which he supposedly created when he was a child. And a quick anecdote here that I copy-pasted. The legend says that his math teacher asked the class to add number 1 to 100. In other words, the teacher wanted them to add 1, 2, 3, 4, 5, all the way up to 100. The teacher assumed that this would take the student a very long time, but Gauss answered 5050 almost immediately, which is insane, because even with the formula, I wouldn't be able to say it at least for like 1 minute or 2. I'm not very smart. So the formula is n plus 1 times n divided by 2, and you can find the proof and explanation here. But a quick explanation would be, so 10 is n in this case because there's 10 terms. So 10 plus 1, which is n plus 1, and that's 11 in this case. And 9 plus 2 is also 11. And 8 plus 3 is also 11, and 7 plus 4 is also 11, and 6 plus 5 is also 11. Now we got 1, 2, 3, 4, 5 pairs of 11s here. That means we have half, which is n, because we paired each of them, which is divided by 2. And we can use that formula to find the number of terms. And let's try it out. We'll first do it manually, and then we got a squared, b squared, c squared, d squared, e squared, ab plus cd plus AD plus AE plus BC plus BD plus BE plus BCD plus CE plus DE. And if you count it, that's 15 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we can try the Gauss summation, which is n plus 1 times n divided by 2. Now we just punch the numbers in. 5 plus 1 is 6, 5 divided by 2 is 2.5. Multiply those together and you get 15, which is exactly the same as 15 over here. And therefore, we can assume that the formula works. And now we can go even further by using the modified formula, n times n open bracket square bracket square n times n plus 1 divided by 2. That's probably not the right way to say it, but whatever. Now we just punch the numbers in again. 5 plus 1 is 6. 6 times 5 is 30, and 30 divided by 2 is 15. And this formula is exactly the same thing as the one before this formula, but it's just rearranged. And therefore, we can use the Gauss summation formula to find the number of terms in the expanded form of squared polynomials.